So we're going to solve transport equations with initial data, right? Then we'll look at some nonlinear transport equations. Did we have any in this question? Okay, we didn't have. Okay, we'll start from here, then we'll look at some nonlinear transport equation with initial data. So suppose we have f of ux minus 3 uy equal to 0, right? So we know that this is homogeneous, so we can just write this as this, blah blah, u equal to 0. Okay, so we can solve this as we did. So this is u has variables x and y, so we can say the change in y over the change in x equates to negative 3 over 4. So we can separate this, so dy is equals to negative 3 over 4 dx. So we can integrate both sides. So integrating this side, we have y equal to negative 3 over 4 x plus some function psi. Okay, some variable psi constant. So we make psi subject. Okay. So actually here we can, before we would have introduced, would have said 4 times that, 4 times dy, so that it is simpler, right? Would have said this. This is what I'm saying here. Before we do this, let me just separate this as 4 dy is equal to negative 3 dx. Okay. So that we have 4 y negative 3x plus psi. Okay. So we would still distribute by 4, then we would have something, but we can do it like this, right? So now we make psi subject, so psi will be equals to 4y plus 3x. Okay, meaning that f of psi will be equals to f of 4y plus 3x. Remember, u of x comma t is equals to f of
x comma y,
or x comma y in this case is equals to f of psi, which is just f of 4y plus 3x. Okay, so we're here. Now suppose we have some initial data. Okay, suppose we have initial data u of 0 comma y equals to sine y. You are asked to find the general solution if you have this initial data. So what you do is, you see your u is this. So you know that your u of x comma y, which is equals to f of psi, is equal to this 4 f of 4y plus 3x. So where there is x, they're telling you to put 0. So u of 0 comma y equals to f of psi, okay, which would be f of y, okay,
f of 4y,
f of y, which would be equals to f of 4y. Okay, let me just remove this part so that it's less confusing. So I can just say f of, where there is x we put 0, so it should be f of y. Okay, so now remember we have u of x comma y equals to f of 4y plus 3x. This is what we have. And here f of 4y is equal to what? Sine y. Okay, so now we want to write f of y f of y. Okay, what we can do is we can say where there is y, we have 4, we put y over 4. Where there is y, we put y over 4, meaning that this side you can say sine, where there is y, we put y over 4. See that? So that we get rid of this 4. And our f of y would be equals to sine y over 4. So now to find the general solution, we'll say since u of x comma y is equals to f of 4y plus 3x, this would be equals to f of y. Where there is y, we can replace this.
Okay. That the whole of that becomes y.
Yes. So f of y here. So this one, if we replace where there is y here, we replace also where there is y here. So f of 4y plus 3x will be equals to sine, where there is y, we replace 4y plus 3x over 4, which can be simplified as sine y plus 3x over 4. So this will be the general solution given the initial conditions. Okay, so that's the general idea. So there will be cases where you have to solve an inhomogeneous system of equation, but the procedure will be the same. So first of all, you get the homogeneous part. You solve it as you would solve a directional derivative. Okay, you find your y like that, then you find your psi.
Okay.
After you find your psi, you write f of psi equals to f of whatever we have there. Then u is equals to f of psi, okay, which is equals to this. Then if we had a non-homogeneous part, we would have to solve the homogeneous solution. After we solve the homogeneous solution, then we come and replace. Okay, so now the initial condition is u of 0 comma y equals to this. So we get our function where there is x, we put 0, and where there is y, we leave it. So this would be f u of xy, which is equals to this. Where there is u, you put 0, so it will just be the y part. Sign this. But you want to write this in terms of, you just want a y so that it will be easier to replace, right? So you can say f of y is equals to y over that. Okay, then now you find your f of y using this. So u of xy is equals to f of this. So now where there is y in f here, you can replace with this, then it becomes that, and that will be your final answer.
Okay.
Any questions on that one?
Okay.